Welcome to The Explainer. So today we're diving into a classic thought experiment, one that's fascinated people for ages. So what if you could actually jump into a tunnel that goes straight through the center of the Earth? I mean, really think about it. Would you just pop out on the other side? Well, let me tell you, the real answer is way more complicated, and honestly, a whole lot more interesting than you probably think. All right, let's really get into this. Because that simple answer you might have heard in a physics class, the 42-minute trip, well, that's hiding a reality that's not only more complex, but also way more dangerous. And spoiler alert, it's not 42 minutes. Okay, so first things first, let's build the perfect physics classroom version of this fall. To get that classic answer, we have to imagine a very, very specific and, let's be honest, a totally impossible scenario. So picture this, right? A perfectly straight tunnel stretching over 12,000 kilometers right through the heart of the planet. And inside, it's a perfect vacuum. No air, no friction, you don't even touch the sides. The only thing doing anything to you is gravity, just pulling you from one end of the Earth to the other. Now, the key to this whole classic problem, the thing that makes the math work out so elegantly, is one big assumption, that the Earth is basically a giant, solid bowling ball. Same stuff, same density all the way through. It's a simplification, for sure, but it gives us a really clean answer. And that super clean math? It spits out this famous number, 42 minutes. In this perfect little physics world, you'd basically become a human pendulum, oscillating back and forth forever. It's a perfect example of what's called simple harmonic motion. But, and you knew there was a but, our planet is absolutely nothing like a simple uniform ball. So, let's leave the textbook answer behind and see how the real Earth, with all its layers, completely changes the game. This is where a simple physics problem turns into this amazing dive into geology, and things get really interesting. Yeah, so to get this right, we have to toss out that whole bowling ball idea. Instead, we need to look at what scientists actually use. It's called the Preliminary Reference Earth Model, or PREM for short. Think of it as our best possible map of what's inside the Earth. A map built by studying how earthquake waves travel through the planet for decades. And what PREM shows us is just how complex our world really is. It's not one solid thing. We've got this super thin crust we live on, then a huge rocky mantle, then a swirling liquid outer core made of metal, and right at the very center, a solid, super dense inner core. The big takeaway here? The weight, the mass, is not spread out evenly, not even close. Okay, so this is where things get really weird, kind of counterintuitive. You'd think, right, that as you fall deeper, all that rock and stuff above you would start pulling you back up, canceling out some of the gravity from below. You'd expect the pull to get weaker, but that is not what happens. Believe it or not, for the first part of your fall, gravity actually gets stronger. So why? It all comes down to density. That core is just so incredibly dense, so much heavier than the mantle and crust. As you fall through the mantle, you are getting closer and closer to that super heavy core, and its gravitational pull just completely dominates. So get this, you're not just falling, you're accelerating faster than you would if you jumped out of a plane. Right around the edge of the core, the gravitational pull is about 9% stronger than it is here on the surface. That's a huge difference. And that extra gravitational kick acts like a giant slingshot. It literally shaves 4 minutes off that classic 42-minute trip. So now we're looking at a much faster and, frankly, more violent 38-minute plunge. You'd blast through the center of the Earth in just over 19 minutes. And the speeds we're talking about, they're just astronomical. As you shoot through the Earth's center, you'd hit a top speed of almost 10 kilometers per second. To put that in perspective, at that velocity, any kind of collision, even with a tiny object, would have the destructive force of a massive bomb. Okay, so we've got the physics down. A 38-minute trip, insane speeds. But what about you, the person actually falling? Let's just pretend for a second we could magically build the tunnel. The fall itself, well, it's a gauntlet of completely unsurvivable dangers. I mean, let's just list the ways you'd die. 1, the Earth is spinning. The Coriolis effect would send you careening sideways, slamming you into the wall at incredible speeds. 2, what if there's air in the tunnel? That air would compress in front of you and heat up to temperatures hotter than the surface of the sun. You'd be vaporized. And 3, even in a perfect vacuum, the walls of the tunnel itself are thousands of degrees hot. You'd be cooked by the radiant heat in an instant. There is literally no way to survive this trip. All right, so the journey is fatal, but what about just building the tunnel?
This is where the problem goes from being just deadly to being completely, fundamentally impossible. The physics are one thing, but the engineering challenge is just on another level.
This really puts our limits into perspective. The deepest we have ever drilled into the Earth is about 12 kilometers. And that was a huge deal. But that's just a tiny pinprick. It's less than 0.2% of the way to the center. We haven't even gotten through the crust. And down at the core, the conditions are just hostile, beyond imagination. The pressure is over 3.5 million times what we feel right now. It would crush our strongest materials like they were made of paper. And the temperature? It's almost as hot as the sun. There's simply nothing we could build that wouldn't be instantly crushed and melted.
And don't forget, you're not just drilling through solid rock. The mantle, it flows like a super slow, super hot river of rock over millions of years. And the outer core is literally a giant swirling ocean of liquid metal. Any tunnel we tried to build would just be squeezed, melted, and completely swallowed up by the planet itself.
Okay, so the tunnel is impossible. The fall is 100% fatal. So why do we even bother talking about it? What's the point of this whole thought experiment if it can't ever happen? Well, it's because this impossible question is actually a perfect tool. It's one of the best ways to really explore and understand our own planet from the inside out. It makes us grapple with the real structure of the Earth, the weird way gravity works on the inside, and those mind-blowing temperatures and pressures that are churning away right under our feet. So yeah, it was never really about a new subway system. It's about how this one simple question acts like a key, unlocking the secrets of our world. It peels back the surface and shows us the incredibly powerful, dynamic, and even violent engine that's running our planet. And when you really think about it, this whole impossible journey, it isn't just a lesson in geophysics. It's a lesson about our place in the universe. It shows us the immense power of the planet we live on, and it really drives home just how thin, how fragile that little crust we call home truly is. It's a pretty humbling thought, isn't it?